Parametric curves, our day one assignment. We're looking at problem 23. And in problem number 23, when we look at our packet, there are two things that we're asked to do. We want to find points, x comma y, coordinates, where the tangent line is A, horizontal, and B, vertical. Well, tangent lines, I'll tell you what, guys, that means dy dx. We've got to find a derivative. And plain and simply, the derivative is dy dt all over dx dt. So dy dt, well, the derivative of -1 plus sine of t, well, that's just cosine of t. Dx dt, well, the derivative of 2 is 0, derivative of cosine is negative sine. Now, I think it's very tempting to say, oh, let's write that as negative cotangent of t, and we certainly may. We may do that. However, when we're trying to find horizontal tangent lines, and I know we've dealt with that time and time again, that's where dy dx is 0. And if you've got this fraction, I hope you can see plain and quickly that a fraction is 0 when its numerator is 0. So I'm going to say i.e. dy dt equals 0. So that means let's just set cosine of t equal to 0. Let's remember our unit circle. Cosine is the x-coordinates there, so where would we find on the unit circle that the x-coordinates were 0? Well, that'd be at pi over 2. Down here we could call that 3 pi over 2. We could also call it negative pi over 2 if we'd like. So really, we could go coterminally. We could say that there's more than that too. We could, add 2 pi each time. However, you're really just going to get the exact same values for sine and cosine at the end of the day. It's sufficient to just go one trip around the unit circle. Well, remember that, our x-coordinate is 2 plus cosine of t. Our y-coordinate, and we're looking up here, is -1 plus the sine of t. So when t is equal to pi over 2, well, the cosine of pi over 2 is 0. 0 plus 2 is 2. The sine of pi over 2 is 1, and 1 plus -1 is going to be a 0. We could also do this with t equals 3 pi over 2. Well, you could see our x value again, the cosine of 3 pi over 2 is going to be a 0, so you'd get 2 plus 0 right there. At 3 pi over 2, be careful. Sine of 3 pi over 2 is -1, and -1 plus -1 would be -2. So that's where, for part A, we're getting those two answers. Now, tell you what, I'm going to just come off to the side here. When we have vertical tangent lines, dy dx is undefined. It's your derivative wouldn't exist. The reason why is because dx dt equals 0. And guys, just coming back up here to dy dx, what makes a fraction not exist? What would you have to type in when you'd get an error message on the calculator? Well, you'd have your denominator equaling 0. You're saying negative sine of t would equal 0. And we're going to go back to our unit circle. Sine is the y coordinate. And there'd be two values, 0 and also pi, where that would happen. So once again, we'd have x equals 2 plus the cosine of t. We have y was equal to -1 plus the sine of t. And we're going to plug these in. We'd say, well, at t equals 0, well, cosine of 0 is 1. And 2 plus 1 is going to get you a 3. What about the sine of 0? Well, the sine of 0 is 0. 0 plus -1, you get -1. T equals pi. Well, here we go again. Cosine of pi is -1, isn't it? Be careful with that. 2 plus -1, you just get a 1. And the sine of pi is still a 0. 0 plus -1, you get that right there. So here are your 2 points where you would expect to see a vertical tangent line. Your derivative dy dx would not exist.